Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week with me, Katie King. Everyone in the Naked Scientist office knows that I love space, so I was very happy when this question came in from Matt.
Early commercial flights were scheduled and had air traffic control, but pilots were allowed a fair amount of latitude in the early days, which resulted in some mid-air collisions. I was wondering, with 3 space missions currently converging on Mars, how do the nations involved avoid orbital collisions? Do they share data? Do they have transponders or space traffic control? Thank you.
Matt, I spoke with Chris Bridges, academic at Surrey Space Centre in the University of Surrey, to find out more about your question. Let's see if you were right. Do they share data? Do they have transponders? Or perhaps even space traffic control? Let's find out more.
So fortunately, there are not many missions out of Mars. Only about 8 or so missions are currently orbiting the planet. And if we compare that with the 34,000 objects around Earth, Mars orbits are practically empty. Each mission does indeed share data on position and speed, and we call those the state vectors of a given satellite. And this data is shared between all major agencies like NASA, ESA, plus our own UK Space Agency.
You were bang on the money, Matt. Congratulations. Nations do share data. But how is this data obtained?
For almost all missions, we use something called the Deep Space Network, and that uses a transponder to take highly accurate radio measurements to determine what we call the range and velocity.
Right again, Matt. They do also use transponders, much like aircraft send their position to air traffic control. Before answering your final question, though, I want to know, how do we determine the position and speed of a spacecraft when it's so far away?
The actual thing that we're measuring is signal lag and the Doppler shift, which gives us then a change in frequency, and we use these to determine the distance and the speed around a spacecraft at Mars.
Much like when sirens whiz past you on the street and they start to sound different due to the Doppler effect, we can use the frequency of the radio signals to determine how fast these spacecraft are going. Okay, Matt, the final question. Can you get the hat trick? Is there a dedicated space traffic control?
We don't have big space networks. We rely on a combination, really, of special messages and, critically, that operators actually share their information, like GPS data. So we have to work together that our spacecraft aren't on track for any collisions, and especially in low Earth orbit, we use thrusters to manoeuvre away if we needed to, and we often budget for this in our missions.
So, Matt, I'm afraid you didn't quite get the hat trick, as there isn't yet a dedicated space traffic control team. But as the use of space is growing so rapidly, maybe it won't be long before one exists. Thank you to Chris Bridges for your answers, and next week we will be answering Sarah's question of...
Why do ant bites hurt so much?
So if that sounds like a scratch you want to itch, you can join in the debate on our forum over at nakedscientists.com/forum, or send us your own question by emailing chris@nakedscientists.com. I'm Katie King, and until next time, goodbye.